Afternoon, morning, lunch-ish. Welcome, everybody. Thank you for coming to talk about battery. So it's another year, and I'm here again to talk to you about power. It's an ongoing project, and as you probably saw from the keynote, Dave talked about Maslow's, or his own version of the pyramid, and I think it's actually like a lot is in this image. Battery is foundational to everything you're doing on your phone, right? If you don't have power, you don't really have any of the cool features. You don't have the camera. You don't have the assistant. Battery exists to power all the other things. And it's a struggle for us, and it's a struggle, I think, for all of you as well, is you want to do awesome things for users. And you also want to save power so they can do those things for longer. And battery is actually a really easy problem to solve. If you just kill everything. Fixed, I'll take my promotion. It's great. The problem is it's obviously much more nuanced than that, and that is a struggle that we have internally every day, talking about power and what are the right trade-offs for users. And that's always a really hard question, and we're going to talk a little bit about that and some of the things that we're building into Android P to make it a lot easier. And so the first thing I want to talk about is where is it going? And this is like a horrifically simplified. I'm sure some of the engineers out there are like, oh my God, he's showing this. But you have hardware. Things even like how much RAM you have in your device cause a persistent drain on what's happening there. So what hardware the OEM has selected, what hardware you're using, how big your screen is, how bright your screen is, all play into that effect. You have the OS itself. Is the kernel being really efficient? Is it waking up a lot? Does it have a lot of overhead? Do you have disk encryption? Is that disk encryption in software or hardware? Those things all affect then your overall power profile that's happening under the hood. The next thing is apps and services, and this is where we're going to spend a bit of time talking today. Obviously, what apps you have on your phone and the services running on that phone drive power substantially, largely through the CPU and through network connectivity. And then the last one is the user's interaction with the device itself, how they behave, what applications they use, how quickly they respond to notifications or don't. All impact the overall picture of where battery ends up. Really complicated topic. We're going to talk largely about the bottom left corner today. But the thing I wanted just to give is, before we get into that, is what other things have we done, and how does the stuff we're going to talk about in P affect the overall strategy? So we started out with Lollipop with Job Scheduler. And Job Scheduler was a very powerful tool to avoid apps just having to hang out on services all the time, processing in the background. But you could schedule a piece of work and have that piece of work done in a finite amount of time, and the OS could then have some variability on when to schedule it. Next, we did Doze. And Doze was largely targeted at cases where you have your tablet or a phone, you put it down, you're not using it, you put it in a drawer, and you forget about it. And hopefully when you pull it back out and use it again a few days later, it still has battery. And Doze was really trying to target that problem and was largely successful at dealing with that. We had to go further, though, and that was with Doze on the go, or Doze Lite, as we tend to call it internally because it's just faster. That was targeted at phones. And like, I have my phone hanging out in my pocket. I'm not using it right now, but I'm moving around, so I'm not in a drawer. That is then the next step, was how do we get that to be a good scenario? And Doze on the go is trying to look at that scenario of your phone screen is off, you're maybe moving around, so you're probably not wanting all your apps to be quite as severely restricted as full Doze, but you still need to be a little bit backed off normal scenarios where the screen is on. We still needed to do more and go deeper. The next thing was looking at background limits, and this was largely targeted at background services as a whole. Now we'd had jobs around for quite a while. We also were looking at background limits for location and trying to figure out what's the right balance of applications looking at location in the background versus the foreground, and should there be different thresholds of what is appropriate. Really good effect with that. The only downside, if you will, to what we did with Oreo was we needed apps to target the Oreo SDK. And I'll talk about that in a moment in order to support this. And then P, obviously, since we're here, we're going to talk about some more stuff that we've been working on. The one thing I wanted to take a moment, because we're mostly going to talk about really cool ML and other exciting things, is there was a lot of just brute force optimization that the engineering team has also done. This was looking at F2FS file system work. This was looking at how do we choose between whether a process should be on a small core or a big core, looking at when we should do CPU boost so that you have nice, buttery smooth sliding, but you're not just burning power when the screen is on in anticipation that the user might interact with the screen. And these were all a bunch of things that have been done over the years. This is a set that we just did on P, and there's probably still more that we're trying to get done. And then the thing is, there's still some of those big challenges that are remaining, and this is what we're going to talk about today, is what we noticed was battery drain was roughly proportional to the number of apps you had on the phone. Not the number of apps you were using, but how many you had installed. And obviously that's not ideal. And so we wanted to try and remedy that. We also saw a lot of scenarios where apps are accidentally making mistakes. Like if you're working with wake locks, you're kind of playing with fire. And what happens when a mistake happens? And usually battery would suffer. Also, some developers would be really aggressive with their use case and trying to be like, oh, I must be there all the time, ready to go at a moment's notice. And sometimes that might take an awful lot of battery to achieve that. And is that really in the interest of the user? And how can we help balance that back out? And because the last part is, even when an app was aggressive or an app had a mistake, it wasn't obvious to the user as to what to do. They didn't know, is the battery menu going to help me? Does it tell me everything? Does it catch all the cases, some of the cases, none of the cases? And even when you saw a high battery value, now what? Do I uninstall? Do I live with it? Do I call up the developer and send them a nastygram? And so that's something else we wanted to really look into. And then the very last one that I mentioned before is the Oreo SDK, having apps targeting that SDK to say, I understand how the background limits work. I understand how I can use jobs and use alarms instead of using services. As you probably saw, there was an announcement late last year talking about targeting requirements for applications on the Play Store. If you haven't seen that, please go Google that and find out about it. You should be looking at it because those requirements are kicking in later this year. And that's going to ensure that then on P, the majority of the apps on your phone are now running the Oreo SDK, and all these features we're talking about work. So the high-level thing we're going to talk about here is a feature called adaptive battery, which I think was been talked about in a few different talks already. Talk about battery saver and trying to make battery saver better, and then also additional restrictions around background processing that we've been looking at, and this is also how to help users understand when can I make it stop? Can I have another choice other than uninstall? Something in the middle between live with it and remove it. And that's like this kind of pyramid's trying to articulate here is we all want good power efficiency. Right? We like batteries that last a long time. We want really cool apps. And we don't want the user to have to manage between these things. Like, do I want cool apps or do I want power efficiency? No one wants to have to be forced to make that choice. It's horrifically difficult. I don't want to make it. No one wants to make it. We want it just to work. And that's what this whole project has been all about. And so with that, I'm going to invite James up here to talk about adaptive battery. Thanks.
Thank you very much.
Enjoy.
Cheers. Hi, everyone. Good morning. I'm James. I'm representing the DeepMind team today. Just wanted to say that we're really pleased to be here and working with Android and excited about what we've built together. So, as a user, you shouldn't have to closely manage how your apps behave on your device. A modern, intelligent operating system should just take care of it. And that's where machine learning can help. We've co-developed this feature with Android called Adaptive Battery. It intelligently aligns app power consumption with app usage. Apps can still run in the background when they need to, and users don't need to micromanage. So Adaptive Battery uses the concept of app standby buckets. Every app on the device is assigned to one of these buckets. Each bucket has different limits on background activity, and there are 4 buckets ranging from active to rare. Apps in the rare bucket will have the most restrictions. And we use the ML model to assign apps to buckets based on their predicted usage. So, for example, apps that are predicted to be open in the next few hours. I'm here at I/O, so I might be using the I/O app. So the I/O app is going to be in the active bucket. But in a few days' time, when I'm back at home, Adaptive Battery is going to automatically determine that I'm unlikely to be using this app and put it into the rare bucket, so it's not unnecessarily consuming resources like battery. So what are the restrictions that are applied? Jobs, alarms, Firebase cloud messaging, and network are all restricted in Android P depending on which bucket the app is in. Apps in the active bucket have no restrictions, just like it is today. Working set has some restrictions on jobs and alarms, and frequent and rare buckets introduce restrictions on the number of high priority Firebase Cloud messages. Messages beyond that cap will be treated as normal priority, so they'll be batched together with other messages to save battery. Generally, as developers, you should assume the background activity will be deferred and ensure that your app can work under those conditions. But one thing to remember is that once this device is plugged into power, all of the restrictions are lifted. There are ADB commands that you can use to test your app in each bucket to make sure that it performs as expected. You can also use new framework APIs to get your app's current bucket at runtime. Most apps should be fine if they're already following best practices, such as using jobs for background work and targeting recent API levels like Android Oreo. As Ben just said, this is going to be a requirement for app updates on the Play Store later this year, so please make sure you're targeting the latest SDK versions. So let's talk a little bit about machine learning. The model was built by Android and DeepMind to predict which apps go into which bucket. Now, we could have done this with simple heuristics, or we could have even just used past behavior on the device. But we found that machine learning allows us to capture the nuance of how users behave with their apps. And I'll go into some detail on how we built the model in a second. For those of you who are interested, in the architecture of the model, we're using a 2-layer deep convolutional neural net with a feed-forward neural net on top. And this is used to predict the probability that an app will be opened in a given interval. You might have heard of convolutional neural nets before. Particularly, they're quite common in image classifiers. But we've used them here to measure higher level patterns of app usage over time. It turns out they're pretty good at that. Now, all of this is happening on device using TensorFlow. And that's actually a first for DeepMind. We've never deployed production models on the compute power of a single device. And a single mobile device with the limited compute power that's available is a particular set of challenges. And of course, we're building this machine learning model with the intention of attempting to save power. And if we are doing machine learning on device, we have to be careful that we're not spending more power than we are saving. We're going to be making this model available to all device manufacturers, so they can take it if they wish for their devices on Android P, or they can implement their own, or they can take an Android open source version of it as well. So the model. We trained the model on millions of sequences of app opens and transitions to discover the patterns of how users behave. So an example would be, if you use an app at 8 o'clock in the morning every morning, you're probably quite likely to open it tomorrow at 8 o'clock as well. But if you only use a certain app on weekends, like a game or a travel app, then you're probably not going to open it on Monday morning. And the model is able to capture this nuance. The model looks at the user's behavior and outputs a probability of when you're next going to open a particular app. The model compares the usage to the patterns we've observed in the data, and the behavior on device will influence the predictions given by the model. So we've also built this model with certain principles in mind. We've tried to make it fair. There is no favoritism of one app over another. If you use one particular app in exactly the same way that I use a different app, then the model will output the same predictions, and they will be assigned to the same buckets. It's privacy sensitive. There's no personally identifiable information used by the model, both when it's trained and when it runs on the device. The model only compares the app usage on device to our known sequences of millions of app transitions, and it predicts when you're next going to use that app. So if you combine the app standby buckets and their restrictions with this model that predicts when you're next going to open the apps, that's the adaptive battery feature. It's a system that adapts the phone to you. The output of the model is used to personalize the OS's behavior to adapt it to how you use the phone. So the apps that you use get to run in the background, and the apps that you don't. We hope this will create a more consistent battery experience for users. I'm now going to pass over to Madan, who's a product manager on Android, to talk about the battery saver features. Thanks very much.
Good job.
There you go, man. Good.
Thank you, James. So let's talk about battery saver. Many of us actually run through the day, and as we end towards the day, we realize that, oh, I won't be able to actually make it. And battery saver is there to actually save you. Remember those red bars when our animations that were janky in Oreo? Who liked those? So we got rid of them. We also actually turned off location. That helps battery. In addition to that, many device-specific features, like ambient display as an example, are also turned off. All of these add up in order to save battery and prolong the device battery so that you can go back and charge the device. We have also made some changes in the UI so that you can live on this mode for longer. Now you have a slider that you can actually increase all the way to the right, which probably allows you to stay on this mode if you choose to. But what's also interesting is, what we found is, if an app is being used by the user in this mode, having a dark theme really helps. Our internal tests show that apps using dark theme save power compared with the ones that don't. So if you are a developer that already supports dark theme, please do think about switching to dark theme when you detect that the device is in battery saver. There are a few commands that you can use through ADB to force the device into battery saver and test them. And for those of you who already support dark mode, there are APIs like ePowerSave mode and a broadcast that you can use to switch your device, your app theme to dark. So let's jump into the battery settings itself. We think when a user actually goes into a battery settings, probably they are having a bad battery day. You want to make the user very easy to take actions. You want to keep the UI simplified. And we will tell you exactly what applications might be causing their battery drain. So we'll be much more opinionated about these things. And in addition to that, as you scroll down, we'll also be able to see how long your battery will last. And that number is also powered by an ML model. So let's jump into that opinionated background restrictions. So we have some principles upon which we have built this particular feature. User asks for controls. They want to know which app is doing what so that they can take a quick action on them. We also want to make sure that apps that don't necessarily target Oreo are also be well managed by the user. And lastly, our goal is to make sure that apps don't get restricted in the first place. So that way, apps fundamentally are a better battery citizens. So with P, we will actually launch this feature with two specific criteria. The first one is if your app is still not targeting Oreo and has a background service. The second one is if an app holds wake locks, or what we call as stuck wake locks, for more than an hour in the background. Both of these are very well understood causes for battery drain. There are more such reasons. We today present those reasons within Play Developer Console, and we call them Android Vitals. So we are, in the future, going to be looking at many such signals in order to incorporate into coming up with new rules for background restrictions. So what does it mean for your app in case if the user decides to restrict them? As James talked about, jobs, alarms, services, and network, the apps will not be able to do any of those in the background. There are some explicit intents, for example, location, will not be delivered to those applications. So we're trying to minimize the reasons why an app should be able to use device resources when it is in the background. And lastly, if an app is in the background and restricted, it won't be able to use foreground services. So as I spoke earlier, I hope many of you are already familiar with Android Vitals. If not, I would strongly recommend you to go take a look into what signals do we actually show in there today and how your app is behaving. We have heard many success stories of application developers using this data in order to improve their applications. And we, in fact, use some of these signals internally also to make OS better, trying to figure out what kind of changes we could be making in order to have the right guardrails within the OS to make sure that apps necessarily don't accidentally drain battery. There was a session about it. If you haven't had a chance to listen to those, please take a look at the recording. So we made the UI simplify, but there might be several of you who would fall into as power users. So you do like graphs, and you do like number or percentages. So we do have it in the overflow menu. Now the graph is improved via better predictions, and the user can take action from this screen if you see any app that is not necessarily that surprises you as being consuming more battery. So from here, you can directly preemptively restrict applications or unrestrict them. This is a good user control for users to have. So how do you test for this? Again, there is ADB commands that you can use to put your app to a restricted state or unrestrict them and test them while they are in the state. Note that even an app that has been restricted could still be used by the user by launching them explicitly. So you want to make sure that they still work. So we have gone through some of the key features in P. And what does it mean for you as an app developer to continue to actually deliver your features using various affordances that the OS offers, like jobs, alarms, and so on and so forth? What does it mean for you to do a background work? You might have actually seen this flowchart before Ben presented last year. It literally went through what is it that you want to do and offered some choices. We want to simplify our recommendation. And thanks to Jetpack, in it we have a great tool. So it's extremely simplified now, hopefully. So if you want to think about doing anything in the background, we highly recommend you to actually evaluate Work Manager as a go-to thing. And if you think it is something that is really important and must happen now, of course, you have the ability to use foreground services. But note that if you use foreground services, you have to tell the user why you are using it for, because there will be a notification, and you'll have to justify yourself as to why you think it is important. And now, because of that, if you change your mind, go back to Work Manager. So if none of this work, think about actually doing the work when the app actually is launched and being actively used by the user. So the choices are hopefully very simplified. All of this really help us manage battery better, and that will lead to having a better battery life. There have been some sessions that have already happened, so I want to call Shout out to Jetpack, which talks about Work Manager. There was also a session on Android Vitals, and there is a DevByte video. There is a detailed documentation of the features that we talked about. Please head over to d.android.com/power. And thank you.